Hello dear students, for your exam I selected 13 new questions, so let's start to solve them. Let's make the solutions. So the first question 4, it says in the diagram above, three forces act on an object, find the net force acting on the object. So values of angles are given and values of forces are given here. So let's calculate it. Here we know that if the forces are at angle with the coordinate system, making an angle with the coordinate system, we have to separate each force into components. Here let's start from F1. So look, F1 is equal to 10 newtons, so F1 by X is equal to, we use angle with the horizontal, which is 53, so it will be 10 times cosine of 53, which is equal to 6 newtons. So F1 by Y is equal to 10 times sine of 53, which is equal to 8 newtons. So next, let's F2. F2 is equal to 5 newtons, and F2 by X is equal to 5 times cosine of 37, which is 0.8. So here, if we multiply them, we will get 4 newtons, and F2 by Y is equal to 5 times sine 37, so it will be equal to 3 newtons. The last one, F3, so it is equal to 5 root of 2 newtons. So F3 by X is equal to 5 root of 2 times cosine of 45. It is root of 2 over 2. We can use this one. So 5 root of 2 times root of 2 over 2. Here, all 2's will be cancelled, so it will be just 5 newtons. And F3 by Y will have the same value, because sine of 45 is the same as 45, cosine of 45, So we will get 5 newtons as well. So we defined all the values, but as you see, we know that force is the vector quantity, so we have to take under account their directions here, Now we have to make the table, Table of the vectors. Look, we have F1, F2, and F3. So let's write it like this. This will be, this row is X, and this row is Y component, for Y components, And look, if you see F1, F1 by X is looking backwards, so it will be -6, and Y component is looking up, so it will be just 8, F2. Both are negatives because looking backwards and looking downwards, so -4 and -3. And the last one is horizontal component is positive, it is 5, and the vertical is negative, it is looking back downwards, it is -5. So here, now the last step, we just sum them. We just add these numbers. To define resultant, So -6 minus 4 plus 5 will be -5, and this one is gonna be 0. If you add these numbers, 8 minus 3 plus 5 is equal to 0. So that means resultant vectors components are these ones, -5 and 0. It's a vector which is something like this, Let's draw it here. For example, -5 and 0. It looks something like this. So it has no vertical component, and that means that this is enough. to define the answer. That's it, yeah. And the angle with the horizontal, alpha is just 0, yeah. It's making 0 degree with the horizontal. Question 9. It says express the unit Newton in terms of base SI units. So here, Newton is the unit of force, yeah. So firstly, to define SI unit, we will define it by using equations, yeah, by using formulas. That means force is equal to mass times acceleration. Mass times acceleration. So, and their units are mass is measured in kilograms, acceleration is measured in meters per second squared. Here, kilogram is the base unit, and meters are base unit as well, and seconds are base unit. That means those units are enough to us to find the SI unit, yeah. So meaning, let's write it like this: Newton is equal to kilogram times meters and over second squared. This is our answer. Question 15. Which forces act on an apple when it remains on a tree, falls from a tree, and remains on the ground? So I tried to draw it here. So when it is remaining on the tree, so firstly, we know that gravitational force is pulling it downwards. We can write it F3, and upwards it is holding up by this stem, yeah. So it is called we can say it's a tension, yeah. So there are two forces. When it is falling, if there is no air, only force of gravity is pulling it downwards, is applied on it. And if there is any resistance, if you say that there is a resistance, like air resistance, so we say force of friction is applied upwards here, yeah. So when it remains on the ground, so still gravitational force is pulling it downwards, and because of the surface, we know that perpendicular force, which is opposite to gravitational force, is always a normal force. That's it. Question 19. Find acceleration of an object on a smooth surface as shown in a figure. So here you see two forces. So there are two external forces, yeah? And that means F net. Let me write it here. That F net will be the difference of them because they are in opposite directions. So it will be F1 minus F2. So the F net gives the acceleration of the whole system, of the object here. It will be 40 newtons minus 10. So acceleration is equal to 30 newtons over the mass is 6 kilograms, which will be 5 meters per second squared. That's it. Question 22. Find acceleration of the mass on a smooth surface shown in a figure. So if the first force is 50 newtons and then it becomes 100, yeah. This force is applied at angle. That means it can be separated into two components, yeah. This will be F by X, and upwards it will be F by Y. So let's solve it firstly for A, yeah. So F by X will be just 50 times cosine of 37. So it is equal to 50 times 0.8, which is 40 newtons. Then we define F by Y. F by Y is equal to 50 times sine of 37, 0.6, which is equal to 30 newtons. And now, downwards, it is pulled by the weight of the object, as you see. The downward force is mg. That means mg is equal to 40 newtons, yeah, because the mass is 4 kilograms here. So that means weight is higher than F by Y, which is upward. That means it cannot be, this object cannot be moved by a vertical. That means this object is gonna move only by a horizontal. That means we're gonna use only horizontal forces to define the acceleration of the mass, okay? So F net is equal to horizontal forces Fx, and there are no other forces. That means only Fx maintains the acceleration, ma. So Fx, we define it here, which is 40 newtons is equal to our ma, and acceleration is equal to 40 newtons over the mass is 4 kilograms. So it is equal to 10 meters per second squared. This is for the first one. And now let's solve it for B. Let's solve it for B. It will be slightly different because the forces increase. That means F by Y increases as well. Yeah. So here, firstly define F by X. F by X will be 100 times cosine of 37, which will be 80 newtons, and F by Y will be 100 times sine of 37, which will be 60 newtons. Here, this 60 Newton force is bigger than 40. That means this whole object is gonna move upwards at angle in like somehow in this direction, okay? Because there are two components of this force, yeah. There are two components of F net. So firstly, that means we're gonna define firstly F net by X, then F net by Y. So F net by X is equal to, F net by X is just equal to F by X, which is equal to 80 newtons because there are no other forces. But for F net by Y, it is equal to downward force mg. I'm sorry, you know that upward is higher, bigger, yeah. So it will be F by Y minus mg. So it will be 80 newtons minus 60 newtons. It will be, I'm sorry, minus 40, yeah. So it will be, I'm so sorry guys, it's not 80, it is 60. It is 60 newtons minus 40 newtons, yeah. So it will be equal to 20 newtons. So look, we have two components. We have two components like this. Find the acceleration of the mass. So we know two components. That means actual F net will be equal to 80 newtons squared plus 20 newtons squared and under root. And this will be, just a second, let me calculate it. It will be 82.46 newtons, yeah. So the acceleration of the object is gonna be 82.46 newtons over the mass. The mass is 4 kilograms. Over 4, it will be 20.61 meters per second squared. That's it. Question 30. It says two boxes having masses of 3 and 6 kilograms attached to each other by the rope rest on a horizontal smooth surface. if 3 kilogram box is pulled by the force of 18 newtons as shown if you find the acceleration of the boxes. Acceleration is easy, yeah? So we just use external force, which is F net. External, there is only one force, yeah? If there is no friction, that means only one external force is here, yeah? Which is 18 newtons. And this 18 newtons gives the acceleration of the whole system. It will be mass total times the acceleration. So the acceleration will be equal to 18 newtons over mass total is 6 plus 3. So 18 over 9, it is equal to 2 meters per second squared. So the next question, the tension in the rope. So here, to define tension, we can use one object here. We can look at one object. Let's take this one, yeah? So here, if you see, for the second object, external force will be the tension here. This tension is our external force. So B, that means tension will be our F net, which maintains the motion, yeah? Maintains the acceleration. It will be equal to M 2 n times the acceleration. So tension is equal to mass 2 is 6 kilograms times acceleration is 2, which is 12 newtons of force. Question 54. It says two objects of masses 2 kilogram and 3 kilogram are moved by a force of 30 newtons along the horizontal surface as shown in the figure. Find the coefficient of kinetic friction between the objects. Find the coefficient of kinetic friction between the objects and the surface. If the coefficient of kinetic friction between the objects and the surface is 0.2, what is the acceleration of the system? First question. And find the tension in the string connecting two objects. So here, firstly, we will define all the forces here. So I will draw it here directly. Downwards, this one is pulled by the mg. Here, this one is also pulled by mg. I will write it as different masses, okay, later, but just for now. And then that means this 30 Newton force is stopped by opposite force, and you know it is that force is coming from the friction because of the friction here. That means there are two different force of frictions here. One, force of kinetic friction 1, and force of kinetic friction 2, because of different masses and because of different normals here, yeah? So the next step, what do we do? So in order to define the acceleration, we have to first define F net. So it will be like this. F net will be equal to external force minus force of kinetic friction 1 minus force of kinetic friction 2. So again, F net is equal to force minus, this one will be force of kinetic friction 1 is this one. So here I will replace it with the formula. So it will be mu times m1 g minus mu m2g, yeah, two different masses, yeah. So F net will be equal to F minus, here I can take out of the bracket this mu g, it will be m1 plus m2 in the brackets, yeah. That's it. Let's try to define it. So F net will be equal to 30 minus 0.2 times 10, and the masses, sum of the masses will be 5 kilograms. So it is 30 minus 50 times, what is this? 10, yeah? It it will be 20 newtons. So external force is 30, but net force is 20 newtons. And this F net gives us the acceleration. Acceleration of the whole system. Here mass will be total, okay? It is equal to 20 newtons. So the acceleration is equal to 20 newtons over mass total is 5 kilograms. So it is equal to 4 meters per second squared. So we found the first question, yeah? This one. Let's solve B. Find the tension in the string connecting two objects. So here we can solve it by looking at two different objects. We can use either objects here, yeah? Let's use, it doesn't matter. We're gonna use this one. So here, let's define all the forces here. So it is external force of 30 newtons firstly, and backwards it is pulled by friction of kinetic force 2, and additionally it is pulled by this tension. This tension is stopping the motion, yeah? So from these givens we can make an equation, yeah? It will be F net, this is the part B, F net will be equal to 30 newtons minus force of kinetic friction 2 minus the tension. And we have to define this tension here, yeah? So here, F net, I will replace this F net with the acceleration of the second object. It will be equal to 30 newtons minus force of kinetic friction 2 is mu m2g minus the tension. So the tension will be equal to m2a it is equal to 30 newtons minus 0.2 times m2, 3 times 10 minus the F net, yeah, m2, it is 3 times, acceleration is 4, we define it here. So tension will be equal to 30 minus 6 minus 12. 30 minus 18, which is equal to 12 newtons of tension. Question 2. The tension in the rope is 30 newtons when an object of mass is in equilibrium, as shown in the figure. Find the mass m in kilograms. So here, let's just zoom it here. The tension in the rope, that means it is here. This tension is equal to 30 newtons. And what is the mass of the object? Here, if we see only one rope, that means this is only one rope, right? That means the tension at any point will be the same. If it says 30 newtons, it's 30 newtons at any point. So now we define it here. And downwards it is pulled by the mg, yeah? So that means mg is equal to 30 newtons and mass is equal to 30 newtons over 10, which is 3 kilograms. That's it. Here we don't use this angle. Question 3. An object of mass m is in equilibrium with the aid of the horizontal force of 30 newtons as shown in the figure. Find the mass of the object in kilograms. So, wait, the mass is not given, yeah? Downwards it is pulled by, again, mg in this direction by the force of 30 newtons. And there is a tension at angle here, yeah? So this tension, again, can be separated into two components. This one is tension by x and tension by y. and here. But you can use this angle, but to not make it complex, we just use the angle with the horizontal. If you look at this triangle, if this angle is 37, this angle is gonna be 53. This angle is gonna be 53 degrees, yeah? So we will use that angle. So let's calculate it, yeah? What is the mass of the object? That means in order to define this mass, we have to know the weight. To know the weight, we have to know tension by Y. To know it, we have to know the tension itself. To define tension, we have to know tension by X. So we start from tension by X. Tension by X is equal to the F, because they have the same values to stay in equilibrium, yeah? So it is equal to 30 newtons. Next, tension, that means the tension will be equal to tension by X over cosine of 53. Yeah, that will be 30 newtons over cosine of 53 is sine of 37, which is 0.6, which is 50 newtons. Then we define tension, not define tension by Y, which is equal to 50 newtons, the tension here, times sine of 53. Sine of 53 is equal to cosine of 37, which is 0.8. 50 times 0.8 is 40 newtons. So now we know this tension by Y, that means the value of mg is equal to 40. So mg is equal to tension by Y is equal to 40. And if we just say that the gravitational constant is 10, that means the mass will be equal to 40 newtons over 10, yeah, newtons per kilogram. So it will be 4 kilograms of mass. Question 4. An 80 Newton object suspended from the ceiling is pulled by the horizontal force of F, as shown in the figure. Find the tension in the string. Find the force. Yeah, there are two questions. So, firstly, we will define all the forces. Yeah, downwards it is pulled by the weight, which is equal to 80 newtons. It's written here. Yeah. So then, forward, there is a force. Backwards, I mean there is a tension. Angle, yeah, tension. So this tension can be separated into two components, yeah. I'm sorry. This will be tension by Y and backwards tension by X. And the angle, this angle with the horizontal is, if this angle is 53, that means this angle will be 53 too, because of these two parallel lines here, yeah. So we know the angle with the horizontal, and now we can solve it. We can just solve it, yeah. So here, if the weight is given, that means mg is equal to tension by Y. These two forces are canceling each other, yeah. So it is equal to 80 newtons. Now we know the tension by Y, and from this one we can define tension, which is equal to tension by Y over sine of 53. So it is equal to 80 newtons over 0.8, which is equal to 100 newtons. So tension is 100 newtons, and tension, and now the next, now look, we defined the tension, we solved the first question. Next is the force. We have to define the force. So the force, the value of this force is equal to the value of the tension by X, yeah? So I can write it like this: tension by X is equal to force. That means now I have to define tension by X firstly, yeah? Tension by X is equal to tension times cosine of 53. That means 100 times 0.6, which is 60 newtons, yeah? That means tension by X is equal to 60 is equal to the force. The force value of the force is 16 newtons. Question 5. The spherical object shown in the figure is in equilibrium. What is the tension force in the string in newtons if the reaction force applied to the object by the inclined plane is 30 newtons? Yeah. So here, first step, you have to define a coordinate system. If you see an inclined plane, that means the coordinate system will be inclined as well, like in the same direction as an inclined plane like this. So here, it is better to solve it in this way, yeah? So this will be our x axis and this will be our y axis here. And now let's define all the forces, yeah? Let's try to define all the forces. Downwards, it is pulled by the weight of the object, and upwards at the angle it is pulled by the tension. Yeah. What else? So here there are only two forces. And it says the reaction force applied to the object by the inclined plane. Look, reaction force meaning it's a normal force which is applied from this horizontal. We say that it is a horizontal surface here. So upward force is 13 newtons. So here, what do we do? That means this normal has its opposite force, which is pointing inwards, yeah, inwards in opposite direction, which will have the same value firstly, which is 13 newtons, yeah. And this force is called the mg by y. It's vertical component of the weight, okay? Because here this mg can be separated into two components. This will be mg by x, and this 13 newtons will be equal to mg by y. So here we just defined, yeah, we just defined that mg by y is 13 newtons. So here the next step, what do? We can define the weight. Now we can define the weight by using this angle of 53. Here, let's try to understand. Let's try to draw some triangles. Yeah, here it will be 53, this angle. If I, for example, if I continue this line till, for example, till this point, this, what is this? This angle is making a 90, I'm sorry, not this one. Let's continue this mg vector till this point. So as you see here, it's making a 90 with actual horizontal line. That means this angle, or even this angle, is 37 degrees. So that means now we know the angle with the horizontal. Yeah. Here, let's define mg itself. Mg will be equal to mg by y over, we use sine, yes, sine of 37. So sine of 37 is equal to cosine of 53, which is 0.6. That means 30 newtons over 0.6, which is equal to 50 newtons. That means the weight of the object, weight of this object is 15 newtons. From this one we can define mg by x, yeah. Mg by x is equal to 15 newtons, the weight of the object, times we use cosine of 37. Cosine of 37 is equal to sine of 53, which is 0.8. So 50 times 0.8, which is equal to 14 newtons. Look, this value of mg by x is equal to 40, and meaning the opposite force is the tension, right? There are no other forces. That means it is cancelled by this tension because it is in equilibrium, yeah? So mg by x will be equal to tension, will be equal to 14 newtons. That was the question, I think, yeah? Question 6. The system in the figure at the rest. If the smallest object which is placed on a mass m can cause the system to move, calculate the maximum value of the coefficient of static friction between the mass m1 and the surface. M1 is this one. This one, yeah? So there is a friction. This surface is not smooth. That means there is a friction which is applied opposite to this tension here. So, and this whole system is in equilibrium. So if we add tiny masses here, what happens? This whole system starts to move. That means this friction is static friction, and it is on its maximum capacity. So we can make different equations by looking at different objects here, or even at different points. Firstly, look at this M1, yeah? So let's define how many forces are there. Firstly, there is an M1, and it is pulled backwards by force of static friction, and forward by the tension, downward by mg, and upward by normal. Here we don't need this normal and mg because the object is not moving up and down. They're all this vertically, this object is already in equilibrium. So we need only two forces, Fs and T. So if it is in equilibrium, that means Fs, force of static friction, is equal to tension. So that means static friction formula is mu times the normal, or here there are no other forces, so I can replace normal with just mg. So here we know the gravitational constant, we know the mass, we have to define this mu. So that's why we have to define this force of friction. So that's why we have to define this tension firstly. So now we have to look at the second place, not object, second place, which is this point. The point is O, okay? So we're gonna make an equilibrium equation for that point O. Firstly, let's define all the forces, yeah? I will write it here. There is a point O, and downwards it is pulled by 2 kilogram object. Let's write it directly, 20 newtons, yeah? This tension and all this mass stuff will be just 20 newtons, okay? So, and backwards it's pulled by the tension T, and upwards it is pulled by another tension, let it be tension 1. So these two tension and the force are perpendicular to each other. That means they're like components of the vector, but we have to separate this tension 1 into two components, yeah? It is tension 1 by x, and upwards it is tension 1 by y. So in total we have 4 forces here, 1, 2, 3, 4, except tension itself, yeah, except tension 1 itself. So let's make two different equations for it, yeah? From here we can define tension 1 by y because downward force is already given. So it will be tension 1 by y is equal to just 20 newtons, yeah? Because it is cancelled by this 20 Newton force here. So we defined it. And by using this angle of 37, we're gonna define tension itself, yeah? Tension is equal to tension 1 by y over here. We have to use angle with the horizontal, this angle. If you calculate it, it becomes 53 degrees. So it will be, if we're defining, we are using a vertical component, that means we use sine of 53. So it will be 20 newtons over sine of 53 is 0.8. So it is equal to 100 over 4, 25 newtons. It is 25 newtons. And from this one we can define tension by x. Tension by x is equal to tension times cosine of 53, yeah? So it is 25 times 0.6. 6. So it is equal to 1 Just a second, let me calculate it. 25. So it is equal to 15 newtons. So now we know two components here. Look, I mean, we know tension 1 by x. We know that it is backwards, it is pulled by the tension. That means their values are the same. So meaning tension is equal to tension 1 by x, which is equal to 15 newtons. So we know that, and if you see tension itself is equal to force of static friction, yeah? So that means force of static friction itself is equal to 15 newtons, yeah? Because it is equal to tension. So here we know it. Here we know the value of force of static friction. And let's use that equation, this one. If I rewrite it for the mu, for the coefficient of friction, it will be mu will be equal to force of static friction over mg. That means it is equal to 15 newtons over the mass of the mass 1 is equal to 3 kilograms. It's written here. So 3 kilograms times 10. It will be 15 over 30 or 0.5. Just a number, yeah? It has no units. So that's it. It is correct because we know that coefficient of friction has values between 0 and 1, yeah?